Once again, very good morning. So we will start the class now. In last class, we discussed about the Z parameters. In this class, we will see Y parameters. So Y parameters are also called as admittance parameters. One more name, admittance parameters, or else short-circuited parameters. So Z parameters, they were called as impedance parameters or else open circuit parameters. Similarly, Y parameters are called as admittance parameters or else short-circuited parameters. So unit is Siemens. So unit for these parameters is ohm. Unit for the Y parameters is Siemens. Alright. So it is the reciprocal of 1 by impedance. So 1 by impedance is called as Y parameters. 1 by Z is called as Y parameters. The unit of this is ohm. The unit of Y parameters is Siemens. Alright. It is what two-port a linear network. So this linear passive elements a network RLC that can be replaced with the help of Y parameters here. Y11, Y12, Y21 and Y22. So that complete a network is replaced or represented with the help of Y parameters here. Our duty is to let us define Y11, Y12, Y21 and Y22. The terminal currents are expressed in terms of terminal voltages. Terminal currents are expressed using a terminal voltages using this formula. They are called as equation number 1 and 2. In case of Z parameters, terminal voltages are expressed in terms of terminal currents, so that equations were V1 equals to Z11 I1 plus Z12 I2, V2 equals to Z21 I1 plus Z22 I2. These were the expressed impedance parameters. These are the expressions for Y parameters. I hope you can see the terminal voltages are expressed in terms of terminal currents. In case of admittance parameters, terminal currents are expressed in terms of terminal voltages. Alright. In equation number 1 and 2, they are expressed in terms of a matrix form. Let us define Y11, Y12, Y21 and Y22. Y parameters that we want to determine are these four. The values of the parameters can be evaluated by setting V1 equals to 0 here. You can see the equations. If I do make V1 equals to 0, we will get two parameters that are Y12 and Y22. If we make V2 as 0, in this equation we will get parameters, that is Y11 and that is said here. Set V1 as a 0. What is the meaning of V1 as 0? Voltage is 0 means input port is short circuited. Alright, I will write equation I1 equals to Y11 V1 plus Y12 V2, I2 equals to Y21 V1, Y22 V2. Alright, V1 is 0. In this equation, V1 is made 0. So how V1 is 0? Voltage is 0 means it is the voltage at input side. So that meaning of this expression is input port is short circuited. If input port is short circuited, we do obtain expression for these two values. Alright, that is said here. We will get y12 equals to V1 divided by y1 divided equals to I1 divided by V2. The condition is input port is short circuited. The condition is V1 is input port is short circuited. So from equation number 2, if V1 is 0, so it is 0, we will get I2 divided by V2. I2 divided by V2, the condition is input port is short circuited. Similarly, make V2 as 0. What is the meaning of this? Output port is short circuited. If V2 is 0, we will get these two parameters value. The second condition is, let us make output port as a short circuit. The meaning of this is V2 is 0. If V2 is 0, these two terms will be 0. We will get y11 and y2 expression. So expression for y11 is I1 divided by V1, but the condition is V2 is 0. The expression for y21 equals to I2 divided by V1, the condition is V2 is 0. So is that okay? Right. So what one is called y11 is called here. Y11 is called as short circuit input admittance. Keep that point in your mind. Y11 is called short circuit input admittance, and it is measured in terms of SMNs. Alright, what is Y21? Y21 is called as short circuit. Y21 is called as short circuit transfer admittance. Y21 is called as short circuit transfer admittance. It is measured in terms of again SMNs. Alright, what is this called? Y12. Y12 is called as short circuit transfer admittance. Short circuit transfer admittance. Then Y22. Y22 is called as short circuit instead of input, here it is output admittance. So here we can observe Y21 and Y21 and Y12 namings are same. They are all called as a transfer admittance. One is forward transfer admittance, another one is a reverse transfer admittance. Alright, so these namings are very essential. These namings are very essential. So short circuit input admittance, short circuit output admittance, short circuit transfer admittance, short circuit transfer admittance. One is a forward, another one is a reverse. Is that okay? You should write all these values in terms of namings. Is that okay? Alright, we'll see the next concept. So it is what equivalent circuit of a Y parameters. Equivalent circuit of Y parameters. See here. So what we have written, I1 equals to Y11 V1 Y12 V2, I2 equals to Y21 V1 plus y22 v2. All right, so these values are expressed using equivalent circuits here. All right, so if you apply a KVL at this point, we will get the same expression. So I1 current is entering, these two currents are leaving, so it is at the potential v1 divided by y11. Okay, so what is actually, it is not an impedance here, it is admittance. Keep that point in your mind. It is not an impedance here, it is admittance. What is current flowing through this branch? Divided by actually the admittance, impedance, but here it is, so I write here minus I1 plus V1 divided by, okay, assume that it is Z11 plus, what is this current? The value is given here, V2 into Y12. So what is 1 divided by Z1? What is 1 divided by Z1? It is Y11, V1 plus, you can see here, these two are 1. I1 equals to Y11 V1 plus Y12 into V2. Yes. So if you apply the KCL at this node, we will get the same thing. Minus I2 equals to, this potential is at 2 divided by Z22 plus Y21 into V1. What is 1 divided by Z22? It is Y22. We will get the same expression. Alright, so it is what? It is what? The equivalent circuit of a